Corporate Finance Core, Topic 4, Learning Objective number 2. We're going to value stocks using the dividend discount model. So dividend discount model states that the value of a stock is the present value of future dividends. So we can write that the value today of a stock is the sum of the dividend received at time period T discounted at some rate R for each period T. So we take each dividend divided by 1 plus R to the T. However, we often use perpetuities to value stocks. We just assume they're going to be around forever. So that's going to the formula for that's going to be the price of the stock today will be the dividend paid 1 year from now divided by R minus G. That's my constant growth perpetuity. So what that's assuming is that growth rate of dividends just goes on forever. If that dividend growth rate is 0, well, I can get rid of my G and I can say the price of the stock is the dividend divided by that discount rate R. However, what's generally going to happen is many stocks are in a high growth period. They're going to grow at some kind of extra growth period or high growth period, and then they're going to slow up and then have a constant growth. When you have a model in which stocks grow at some rate earlier, that's high and then possibly low, what you wind up is a formula that kind of looks like this, that you're going to take the present value of dividends over this high growth period where growth is changing usually, and then you're going to apply the growth perpetuity model at the year in which it goes into constant growth. However, the year it goes into constant growth, say 5 years from now that goes into constant growth, and I can assume it grows at 2% forever, I'll take my dividend at say year 5, divide it by R minus G, then I'll discount it back for 4 years to add it back to get it back to the present. So we'll do a couple examples of this for Walmart. So Walmart is currently selling for $109. Say it's expected to pay a dividend of $2.12 per share starting 1 year from now, just to make annual, to make it easier. And then I have an annual analyst estimate that growth is expected to be 3.69% for the next 5 years. So how can we use some of this information to value Walmart? Well, we can do a no growth valuation. I could say that they're expected to pay a dividend of $2.12 per share next year, and say I require a 6% rate of return for taking on the risk of Walmart stock. So that's going to be my discount rate. I'll talk about in another topic how I get to 6%, but I'll just take my dividend over my discount rate, my cash flow over my discount rate, and $2.12 over 6%. That would value Walmart at $35 a share. Remember, it's selling for $109. So let's try another one. What if I use a constant growth model where I use that 5-year estimate of 3.69% growth per year? Well, I would just take my $2.12 over my R minus G, and we'll go ahead and calculate that in Excel. So I'll just go to my Excel file. I'll take my $2.12 divided by my 6% minus my growth rate, and I get a $92 stock price, $91.77. So using this constant growth, using the next 5 years growth rate and a discount rate of 6%, I get a $91.77 valuation for the stock, and the stock price is selling for $109. So not good for investors in Walmart using this valuation. It's a $109 stock that I think is only worth $91.77. The problem with this analysis I just did is this assumption of 3.69%. Whenever you apply a constant growth G for perpetuity, you can never, ever assume that that perpetual growth rate is greater than the growth rate of the economy. So think about it. If you assume perpetual growth is faster than the growth rate of the economy, eventually Walmart will become larger than the economy. It's going to be a long time from now, but if you assume perpetual growth rate faster than the economy, eventually that stock becomes the economy. Now, an estimate for the perpetual growth of the economy would some suggest would be just take the 30-year Treasury bond yield, which at the time of doing this was about 2.4%. So I would say I would never assume a perpetual growth rate greater than about 2.4%. So if I want to do that, but I want to still use the 3.69%, what I can do is use this model where I'll use 3.69% for the next 5 years, then assume it grows at 2.4% forever. So let's go ahead and do that valuation. I'm going to go to my spreadsheet. The first dividend is expected to be $2.12. Then that $2.12 is expected to grow at 3.69%. I'll anchor that 3.69% for the next 5 years. 5 years after that. So I'm going to copy that down. So there's $2.12, and actually I'm just going to take that out to the end of the 5th year. So $2.12 grows at 3.69, 3.69, 3.69, and so on. Actually, let me change this formula here. I want to just take that $2.12 times 1 plus, I'll just use the growth rate to the left here. That way I can just copy the formula down. And these are my dividends for the next 6 years. And then here's my perpetual growth rate of 2.4. And then I'll take the present value of the next 6 years dividends. So I'll take 2.12 divided by 1 plus my discount rate. I'll anchor that. Raised to the year's power. So how much would I pay for 2.12 a year from now? I'd pay $2. Copy that down. So if I summed up this would be the value of Walmart accounting for the next 6 years dividends. How do I account for the dividends from year 7 till infinity? Well, I'll take year 6 dividend. I'll multiply it times the perpetual growth rate. All right, so right here, so far I have the year 7 dividend, right? It's the year 6 dividend times 1 plus my growth rate. That is the year 7 dividend. If I take that divided by R minus G, discount rate minus my perpetual growth rate. So this will be the year 7 dividend divided by R minus G. Whenever you divide something by R minus G, it gives you the value in the year before the cash flow. So this is actually the value of the dividends from 7 to infinity, but it's giving me the value in year 6. So I'll then discount that back at 1 plus my discount rate raised to the 6th power, not the 7th, right? Because that's the year 7 dividend divided by R minus G is the value of the perpetuity from year 7 to infinity. Discount it back to the year before the dividend, which is year 6. So to bring that back to the present, I'll discount that back 6 years. And now I could sum up year 1 dividend, 2, 3, 4, 5, 6, and then 7 through infinity. So I'd value Walmart at $61.66. So this is valuing Walmart using the dividend discount model, where it grows at 3.69% for the first 5 years and then 2.4% forever. So not a very good stock using the dividend discount model. So in this topic, we just talked about using stock using the DDM, the dividend discount model.